Hello everyone, welcome to another demo of the StandardSolver. So you can reach StandardSolver by going to www.standardsolver.com. So in this demo, I'm going to show how to calculate section properties. This is a new feature I added a couple of months back, but I didn't get a chance to give a demo how to use it. So today we are going to solve this problem shown in the left hand side. So this is a cross-section geometry. We want to calculate the moment of inertia with respect to x-axis and y-axis, x being the horizontal axis and y being the vertical axis with respect to its centroid. So let's see how we can calculate the section properties using StandardSolver. So let's go to this section property module. So we want to work with SI unit, and so let's clear our section data table so we have a blank canvas. So let's start adding different sections into the section table, which will form our overall cross section. So let's take the top flange, the geometry top flange. So it's a rectangular section, so we don't need to change what we have here, but we, based on different section shapes, you can select it from drop down, like circular section, then or elliptical sections, things like that. So we are using simple rectangles to create this geometry, so we'll just keep rectangles. There is other options like steel sections where you can get like hollow sections, eye sections. So have a look around and see. So in our case, let's go back to our rectangular section. So this defines the depth of the section, and this defines the breadth, the second entry. So the section we want to analyze has a width of 80 mm. So that's the breadth. Let's enter here, and a depth of 12 mm. So 12. Now just add that geometry. So we have it here. So 80 mm width and 12 mm thickness. We just keep the material as default, everything just 0. Let's add the web. So let's call it web. Then we just keep the same drop down primitive sections. So the depth of the web is 128 mm, and the width is 12 mm. So let's enter 12 geometry. So we added it, but now we can see it's not positioned correctly with respect to the top flange. So let's apply a few offsets to move this web to the correct position. So we know this centers should be aligned vertically. So currently it is at 6. It should be at 40 along the x-axis. So we can apply offset of 34. So now we can see in center. Now we need the web to be below the top flange. So let's try like in a few values and see how it behaves. So we need to go below it, so it should be a negative value. center 128. Oh, so that was the correct value. So now it's below the top flange. Okay, now create the bottom flange. And yeah, just leave everything like this. Then now the breadth is 120 mm and the depth is 10 mm. 10 mm at the geometry. So it is here. Okay, let's first center it by, so the center is currently at 60. We need to be at 40, so we need to move it by minus 20. So now we need to move it by, let's move it by minus 128. Let's see what happens. So it is here, but we need to move it by additional 10 to get this. So get minus 138. So now you can see it's in the correct position. The geometry looks good. Let's see if the mesh. So this is the mesh generated by program. This just to visualize and just to see, like, if there is a gap, the mesh won't pass through. So this is just to see, like, everything is kind of connecting together. All the sections are in contact with each other, so all looks good. So now let's run the analysis. So just a few minutes. This is a quite heavy analysis, so now we got the results. So you can see this red point is the elastic centroid and this green circle is the plastic centroid. So I already have this solution. The moment of inertia with respect to x-axis is 12.46. So yeah, we have in a slight different format, but it will be 12.47 into 10 raised to 6. We just have a different scientific format. And IYY is 1.979. Yeah, there may be slight round off issues, but yeah, generally when we look, it is same as 1.97 into 10 raised to 6. So just a different format, but the values are same. Even centroid, we can see this centroid is actually minus 68.22. that is from the origin. So from the base you subtract this 68.22 from the 150, then you can get it from base. That will come around 69.78, like what's shown here. So yeah, this is how you calculate section properties in StandardSolver. And you can see you can kind of create a complex geometry out of rectangles, then analyze them together and get the properties you want. Yeah, let me know in the comment, you need any other additional properties added here. Like, there is lots of properties I can add. I just thought these will be useful, so yeah, please let me know in the comment. I will add more section property tutorials. This is kind of under testing, I need to tidy up a little bit more, but yeah, I'm doing it in the background. But yeah, just a flavor of things to come. So yeah, thanks for watching the video. Hope you enjoy StandardSolver. Give it a try. I'm trying to make it as simple as possible for you guys to use. And also check out the Discord where you can chat with me. If you have any issue, please join there and let me know. Or you can email also. But yeah, Discord will be really good. And I check the messages every day. So that's it. Thank you very much. Have a good day.